Hi guys, today we're gonna talk about trigonometry, and here we begin. First of all, I want to talk about trigonometric ratios. So we all know, first of all, we all know sine, cosine, and tangent, and secant, and cosecant, right? Now we're gonna learn about their ratios. So let's start with sine. Sine is equal to opposite over hypotenuse. So we pick an angle. In this case, this is the picked angle here, and according to that we choose. For example, according to this, opposite is this, and hypotenuse is always the biggest one, hypotenuse, and adjacent is this one. Adjacent is the under one. So sine is equal to opposite over hypotenuse. So we can write it like this. If you want to write sine alpha is equal to sine, I'm not sure it's beta or alpha. Sine is equal to opposite over hypotenuse. Okay, this is for sine. Let's move on to next one. Now let's do for cosine. Cosine is actually a bit similar to sine, but cosine is equal to, it is similar to sine, but cosine is equal to adjacent over hypotenuse instead of sine, where sine is equal to opposite over hypotenuse. So if we draw a triangle again, it must be a right angle triangle for it to work. Why isn't rubbing it off? Okay, never mind. We can continue with it. So when we draw our triangle, right angle triangle, and we pick the angle, let's name this angle A. So this is opposite, this is adjacent, and of course this is hypotenuse. Okay, so according to this, cosine A would be adjacent over hypotenuse. So this over that. Okay, so you can memorize this from sine, whereas sine is equal to opposite over hypotenuse. Instead, in here it is equal to adjacent over hypotenuse. So whatever angle, hypotenuse is the same, so whatever angle is an opposite, so it is adjacent. Okay, so now let's go to tangent. So tangent is equal to opposite over adjacent. So when we draw a triangle again and again, oh great, okay, so we pick this, let's call this B. Let's try to rub that off if we can. Okay, never mind, it doesn't rub off. So if we call this angle B, for this tangent would be, let's make it fun. Let's name it X, Y, and Z. So what was opposite? Opposite for the B angle, it is X, so it is x over x. So this tangent b, never forget this, tangent b is equal to x, this is our opposite, and y, this is our adjacent, so it's opposite over adjacent. So what it is, x over y. Okay, so this is our tangent. Now let's move on to cotangent. The thing you should remember about tangent and cotangent and sine and cosine, secant and cosecant is that they are opposite each other. For example, there is sine, there is cosine, there is tangent, there is cotangent, there is cotangent secant, and there is cosecant. You must know that to make your life easier, you should know that they are opposite each other. For example, sine is opposite cosine, so sine is opposite cosec, cosine is opposite secant, and tangent is opposite cotangent. You must know this, and trigonometry will get much more easier. So what did we say? Cosec was opposite sine, right? So what if we want to do if you want to find the ratios, this rule will make our life much more easier. So we draw our triangle back again. Hope this, yeah, it's a proper triangle now. It's a right angle, so let's name this x. So what was sine? Sine was equal to opposite, let's give them name, opposite over hypotenuse. This was adjacent, so it was opposite over hypotenuse. So what if cosec is opposite sine, what will be the product? Cosec would be not actually equal. Cosec would be hypotenuse over opposite. So you get it? We just flip this around because cosec is opposite. It's the same thing with the cosine and secant. So what was cosine? Cosine was equal to adjacent over hypotenuse. So what would secant be? Secant will be equal to hypotenuse over adjacent. So what about cotangent? Cotangent, as we said, it was opposite tangent, so cotangent should be, what was tangent first? Let's write tangent first. Tangent was opposite over hypotenuse, so cotangent would be, no, it wasn't this, it was opposite over adjacent, so cotangent would be adjacent over opposite. So you get it? So they are opposite each other. Okay, let's move on. Now let's now look at the unit circle. Unit circle is a really interesting instrument. Let's draw our unit circle. This and this. And guys, never forget, this line is equal to sine, and this line is equal to cos. Okay, so and in if when we draw our circle, let's draw our circle. When we draw our circle, what do we see? In here, sine is positive, and also cosine is positive. And we must know that tangent is the product of opposite over hypotenuse, or sine over cosine is the product of tangent. I mean, the division of sine with cosine is equal to tangent. So if we divide positive by positive, it will also be positive. Let's come here. In here, the sine, it's in top, so this is positive, this is negative, this is negative, this is positive. So in here, sine is positive, but cos is negative because it's in the negative side. So positive over negative is equal to negative. So tangent will be negative. Let's come here. In here, all of them are actually negative. Sine is negative and cosine is also negative. So the product would be, I mean, division of negative and negative would be positive. So tangent is actually positive. Let's look at here. Here you could see that cosine is actually positive and sine is negative, and the positive divided by negative is negative, so tangent would be negative. As I said, this also will make your life much more easier. And then what can we do more? Okay, we must remember that circles are 360 degrees. I mean, you should know it since grade 1, or maybe grade, no, not that, but grade 2, grade 3, you must know that. So from here to here, we call this, I mean, this is 90 degrees, right? So this is 0 to 90 degrees. In here, this is 90, so it's 9, and this is 180 from here to here. So it is from 90 to 180, and from here to here it will be 270. So it is 180 to 270, and from here to here it is 270 to 360. So it increases each time with 90 degrees. Now we call each of the 90 degrees a quadrant. So from 0 to 90 it is called the first quadrant, and from 90 to 180 it is called the second quadrant. From 180 to 270 it is called the third quadrant, and from 270 to 360 it is called the fourth quadrant. Okay, so let's solve some questions. For example, what if the question asks you, what is tan 1? Okay, let's say tan 170. Okay, so it says that determine the sign of the following. So you must find the sign, is it positive or negative? Okay, so if we look at our unit circle, 170 would be between 90 and 180, so it would be here. So what was tan in here? It was negative, right? So this would be negative tan. Or if it asks you sine 80, we will see this part 0 to 90, and in here the sign was positive, so it must be positive also. So we write here positive. So you get the point, right? Okay, now let's move on with it. The circle, what is sine? Okay, so let's say we are given sine is equal to cos over 90 minus. Okay, in here we have to find a number which will, sine is actually positive and cosine is also positive. So when we look at our unit circle, it's 90, and this is some number minus 90, which would keep them in positive zone. So this number could either be 40, so 90 minus 40, or it could be 50, 90 minus 50, which would make this either 40 or 50. So okay, we solved this question. Next. Alright guys, I should also mention that this side is equal to pi divided by 2, because pi is equal to 180. 180 divided by 2 is equal to 90. Alright, and in here it is pi, which is 180, and in here it is 3 pi divided by 2, and in here it is 2 pi. Just keep this in your mind. Now let's solve a question which is about this. So the question is 3 pi divided by 2 pi. Okay, the angle beta is between 3 pi divided by 2 and 2 pi. What is 3 pi divided by 2? It is 540 divided by 2, which is equal to 270 angle beta and 360. So angle beta is between 270 and 360. So the question says that angle beta, or you could say it A or Z. I'll just use A for this. So angle A is between 3 pi divided by 2 and 2 pi, which means between 270 and 360. And it says that, tangent is equal to tangent beta, or A. Let's use A. I like A more than beta because it is more modern. Let's say it is more modern. Tangent A is equal to negative 1 over 2, and it asks you to find sine A times cos A. Okay, let's see how we will do it. We'll of course first of all draw our triangle. Okay, so let's make this angle A. So what is tangent? Tangent was equal to opposite over adjacent. adjacent. In this case, opposite is this side, so it is -1 in here, and adjacent is this side, which is 2. Alright, but wait a second. But look, this is a triangle and the sides cannot be negative. I mean, how can a side be negative? It's like angle being a negative angle. It is impossible. So it is 1/2. So it says find sine A and cos A. Alright, sine A would be equal to opposite over hypotenuse, and cosine A would be equal to adjacent over hypotenuse. So what would this mean? We must first find the hypotenuse. So hypotenuse is equal to, you must know the Pythagorean theorem. So it is 1 square plus 2 square is equal to, let's name this side x, let's name hypotenuse as x, so it is equal to x square. So 1 square would be equal to 1, and plus 2 square will be equal to 5 is equal to x square. So that would make it 5 is equal to x square, and that would be square root 5 is equal to x. So this side is equal to root 5. Let's go to a new page. So let's write down the sine. So let's write down the sine. Sine sine is opposite over hypotenuse, so opposite is 1 and hypotenuse is 5, so it is 1/5 apparently, 1/5, and cosine would be equal to 2/5, 2/5. But there's a mistake. We must multiply them, but when we multiply, it is wrong, because, do you remember this? The angle A, I mean beta or A, is between 270 and 360. What is this? Let's look at our unit circle. 180. This is 270, between 270 and 360. And let's look at cos and sine. In here, cos is positive, but sine is negative. So in our question, it should be sine is negative and cos is positive. So it will be -1/5 times by 2/5, which would be -2/5. Okay, this topic is done. Now let's go to a new topic, which is called the reduction formula with S. Reduction formulas. In this topic there is functions, and there is, let's pick another color, there is cofunctions. So in here, so it's basically like the opposite each other. So in functions, if we have sin, the cofunction will be cos, and if we have tan, the cofunction would be cotan, and if we have sec, the cofunction would be cosec. So what is cofunction? Well, cofunction is basically changing from sine to cos, from tan to cotan, and sec to cosec. So there is of course a formula which is like this: k times pi over 2 plus an angle. So this is the formula. So in here the k is a random number, random odd number, and in here it is, this is the angle, and this is just pi over 2, which is 90. Okay, now let's do an example. For example, let's say we want to find we want to do it for sine pi over 2 minus, it could be positive or negative, minus an angle. Okay, in here the k is actually 1, so the odd number is actually 1. So we would, what was the function of, no, I mean the cofunction of sine? Sine's cofunction was cos, so it would be cos, and what was pi over 2 minus an angle? Pi was 180, so this is 90 minus an angle. So if we look at, if we go back to our unit circle, this would end up in the first quadrant, and in the first quadrant sine is positive. So we don't look at the sign of cosine, but we look at the sign of sine. I mean, when I mean sine, it's positive or negative. So it would be positive, because 90 minus any angle is between 0 and 90, so it should be positive. So that's right, it's in the first quadrant. Okay, let's do another one, another example. Let's say sine bracket 3 pi over 2 plus an angle is equal to what? So is equal to the cofunction, so it will be a cos. So 3 pi divided by 2, it will be between the 180, I mean it is plus, so it will be 270, and between 270 and 360. So if we go back to our unit circle, unit circle, which is here, it is in here, the sign is negative, even though cosine is positive here. As I said, we don't look at cosine, we'll look at the sign for this one, so it will be positive sign. And we also should write the angle. Okay, in later we will learn why. Okay, now we will learn why. Okay, let's start. So what if we are told to find, for example, the same number, the number that matches with sine, let's say 210. So what if they say find the same number, I mean the same angle that matches, which is the same which is equal to the same number. So what we do is sine pi plus 30, because 180 plus 30. So the answer would be equal to sine 30, because we take this number would be equal to this number, so it would be sine 30. It is 180 plus 30. Alright, so and when we convert to sine, we can only use, when we do this, we can only use the angles 90 and 270, but we cannot use 180 and 360 and 360. What I mean that is, so 90 to 100 and to 270, we cannot use these angles to convert from sine to cos. Alright, sine and cos we cannot use. For here it is for tangent and cotangent. Okay, so let's do a summary of the reduction formula. It is like, if we do a summary, it would be like this: sine, cos, tan, and cot, bracket, pi divided by 2 or 3 pi divided by 2, minus or plus actually we just cannot use these angles. Alright, remember these guys, we cannot use these angles. Pi divided by 2 or 3 pi divided by 2, positive or negative. An angle is equal to cos, sine, cot, and tan, positive or negative. Alright, let's now move on to trigonometric ratios of special angles. Let's write this down. Trigonometric ratios of special angles. Okay, so there are two types of special angles that you must know. There are two types of rules. Okay, let's draw our triangle. One of them is the 60, 30, 90 rule. This is a special angle. Okay, so in here we would say this is 30 and this would be 60. In this one, this angle opposite 60 should be equal to k root 3, and this one should be equal to 2k, and this one should be equal to k. The size k is number. This is their, what do you call it, the base. This is the rule. So in the second triangle, we call this 45 45 90 triangle. So when we draw the triangle, it is 90, 45, and 45. And in this one, the rule is that this opposite this and opposite this should be equal to k, and this would be k root 2. Okay, let's solve an example. Let's say, for example, let's open a new page. Let's say, for example, we have this triangle. This is equal to 45, and this also is equal to 45. This is, for example, 3 root 2, and this is equal to 3 root 2 as well. It says we must find this, the x. So what did we say? This is equal to k, this is also equal to k, and this is equal to k root 2. So k is 3 root 2 times by root 2. So x will be equal to 3 root 2 times by root 2, which will be equal to 3 times 2, which will be equal to 6. 6 is the answer. Also, guys, we must know the area. So if it asks the area, the area will be equal to height times dimension over 2. For example, for this one, the height is this, so it is 3 root 2 times by dimension, which is another 3 root 2, the bottom one. 3 root 2 divided by 2, which would be equal to 9 times root 2 over 2, which will be equal to 18 over 2, which will be equal to 9. We could have just cut it from here. It is equal to 9. So what if we put these special triangles in? Alright, guys, now let's look on. So let's see how we will do, what will happen if we convert these special triangles into sine and cosine and stuff, and tangent and cotangent. So let's draw our two triangles. Let's say this one is the 45-45 rule one, 45-45, and this is 30 and 60. So what was 45? K and k root 2, while as 60-30 is k root 3, k root 3, and here it is k, and in here it is 2k. So what if we convert it into sine, cosine, tan, and cotangent? In here also sine, cosine, tan, and cotangent. So let's start with sine. Sine is equal to, as we know, this is the opposite, sine 45 for this and this one, and this is equal to adjacent, and this is 2 for hypotenuse. So for sine 45 it will be k over opposite over hypotenuse, which will be equal to k root 2. So this means k is cancel out, it will be equal to 1 over root 2. So what about cosine? Cosine is equal to adjacent over hypotenuse, which will be equal to k over k root 2, which is like this, which is equal to 1 over root 2. So tan is opposite over adjacent, so it will be equal to k over k, which will be equal to 1. And cotangent is just opposite tangent, k over k, k over k, which will be same as tangent, which is equal to 1. So what did we learn? Sine is equal to 1 root 2. Cosine, this is for 45 degrees. Cosine 45 is equal to 1 root 2, and cotangent is equal to 1, same as cotangent, the same as cotangent, same as cot. Tangent, which is equal to 1. So these are all for 45 degrees. So what about 30 and 60? We are now going to do for 30 and 60. Let's start with 60. Let's do these 60 and we'll open a new slide for 30. For 60, sine is opposite over hypotenuse, which is k root 3 over 2k. So k and k cancels out, which leaves us root 3 over 2. And cosine is equal to, cosine 60 is equal to adjacent over 2k, which means k over 2k, which is actually 1 over 2. Tangent, let's do it this side. Tangent will be equal to opposite over adjacent, which is k root 3 over k, which means it is root 3. And cotangent is just the opposite, as we said, of tangent, so it will be equal to 1 root 3. So what about sine, for 30 degrees? Now let's do for 30 degrees. For 30 degrees it will be like this: sine, cosine, tangent, and cotangent. So sine 30 is opposite over hypotenuse, which is equal to k over 2k. Let's just, to make it easier, let's just draw the triangle here. 90, 60, and 30. And what was the numbers? Numbers were k root 3, k, and 2k. Why does it keep on doing it? Damn. Okay, let's rub it out. Let's make it beautiful. Okay, so cosine is for cosine for angle 30 is adjacent over hypotenuse, which will be equal to k root 3 over 2k. So it is root 3 over 2. And tangent is opposite over adjacent, which is k over k root 3, which will be 1 over root 3. As we said, cotangent is opposite tangent, so it is root 3. So what if we put them in a table? The table would look like this. Let's draw the table. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, and 3. So let's say this is sine, cosine, tan, and cotangent. So this, let's say this is 30 degrees, 45 degrees, and 60 degrees. Sine 30 was 1 over 2. Cosine 30 was root 3 over 2. Tangent 30 was 1 over root 3. And cotangent was opposite tangent, which is root 3. So sine 45 was 1 over root 2. Cosine 45 was 1 over root 2 again, and tangent 45 was 1 and cotangent was 1. 60 sine 60 was root 3 over 2, and cosine 60 was 1 over 2. Tangent tangent 60 was root 3. Cotangent was opposite, so it was 1 over root 3. So this is a table. This is how it looks like after we finish it. So let's solve some questions to understand it better. Okay, the question is tangent 30 times by cosec 60 over cos 45 times by sine 60 is equal to x times cotangent 30 times sine 45. Now the question is to find x. So let's convert these two numbers. So what was tangent 30? Let's look back. Tangent 30 was 1 over root 3, so we write it down. Let's write down 1 over root 3 times cosec 60. Guys, you remember that cosec was just opposite sine, so sine opposite will be 2 root 3, so that would be times 2 over root 3. Cosine 45, 1 over root 2, 1 over root 2 times sine 60. Sine 60 was root 3 over sine 60 is root 3 over 2, so write down root 3 over 2 is equal to x times cotangent 30. Cotangent 30 is root 3, so it's root 3 times sine 45. Sine 45 was 1 root 2, so we write down 1 root 2, 1 over root 2. So let's continue it in the next slide, or actually let's just continue it in this slide and then we'll just move on to the next slide. So 1 over root 3 times 2 over root 3 is equal to 2 over 3 over 1 over root 3 over 2 times root 2 is equal to 2 root 2 is equal to x times root 3 over root 2. Right, it's now time to continue. There's no more space, so that would be 2 over 3 over over root 3 and 2 root 2, root 3 and 2 root 2, root 3 and 2 root 2 is equal to root 3 over root 2x. Is that right? Yep. So let's continue from here. We now will do a let's solve this mess. So this and this will multiply, and this will multiply. So 2 times 2 root 2, that would be a 4 root 2 over 3 times 3 root 3 is 3 root 3 is equal to root 3 over 2x. So now we root 2, we now cross multiply, so it is 4 root 2 times root 2 is equal to root 3, no, it's over, we leave x alone in this side, is over 3 root 3 times by root 3. So that would mean 4 times root 2 is equal, the roots break off and the 2 comes out, and root 3 times root 3, the 3 breaks off and 3 comes out, which will be equal to 8 over 9, which is equal to x. Okay, now let's start then our new topic, which will be trigonometric identities. Trigonometric identities. So I mean, this just became cool. Okay, so in this topic we're going to learn, let's not say rules, but they are actually rules, so but they are identities. I mean, what makes them them? So let's see. The first identity is sine square angle plus cosine square angle is equal to 1. This is our first identity. So for example, 1 root 2 plus root 3 over 2, what the hell, root 3 over 2 square is equal to 1. So that is 1 root 2, what was 1 root 2? 1 root 2 was sine 30 and times plus cosine 30 is equal to 1. Is it true? Now let's see. Sine 30 is 1 over 4 plus root 3 times root 3 to square, I mean 1 squared is 1, 2 squared is 4, and root 3 squared is 3, and 2 squared 2 is 4 is equal to 1. Is it true? Let's see, 1 plus 3 over 4 is equal to 1, and 4 over 4 is equal to 1, and 1 is equal to 1. So it is indeed true. Now let's move on to our next identity. Let's open a new slide. Next identity is tan angle is equal to sine angle over cosine angle. This is our second identity. Our third is, we're gonna solve, but we're gonna solve questions later. Cotangent angle is equal to cosine angle over sine angle. Fourth identity is tangent angle is times cotangent angle is equal to 1. Fifth identity, cosec angle is equal to 1 over sine angle. So cosec is, so we cross multiply, so cosec times sine angle is equal to 1 because we cross multiply. And next identity, I mean, this is it. These are all the identities. So we now learned all the identities. Let's crack on some questions, I say. Alright, let's choose a pen. So let's say sine times cosine is equal to what? So let's see, sine, let's remember sine, I mean sine square, let's say sine square times cosine is equal to what? Let's remember this one, sine square angle plus cosine square angle is equal to 1. So we could say that sine square angle is equal to 1 minus cosine square angle. So when we simplify this, it will be 1 minus cosine square angle times by, let's put our angle sign there, times by cosine angle. So this would mean that cosine square angle minus cosine root cosine quarter times 4 root or 4 square, what do you call it, I don't know, but is equal to what, which is equal to, take out the cosine square. So this is the answer. This is how we simplify it. Alright, let's do another one. Let's pick red this time. Cosine square x times by sine square x times by cosine x. Right? Yep. No, I don't want this. Actually, this is way too easy. Let's make it a bit more harder for you guys. I'm sure you guys can manage it. Oh, what the hell, we'll just forget about it. Okay, so let's say tangent x times by cosine x times by cosec x, right? So let's start. Tangent x is actually equal to, you remember, sine over cosine. This is another identity, sine over cosine. Sine over cosine x times by cos x times by cosec. So let's remember that cosec is also equal to 1 over sine, so it is sine x over cosine x times by cosine x over sine x is equal to, we cancel this and this, this and this is equal to 1. So it is actually kind of fun and puzzling. So this is the best part of trigonometry. After all, when you achieve it, you feel proud of yourself. And actually finding isn't that boring. It's actually fun. It's puzzling. I mean, for me, I like to solve puzzles like these. Alright, never mind me. So enough of me. Now let's continue with trigonometry. The first thing that we're gonna learn is how to find angles and sides which are not special triangles, nor do they have 90-degree angle. So we're gonna learn series of rules and regulations. Let's start with cosine rule. So cosine rule states that a square is equal to c square plus b square minus 2bc times cos z. So let's draw our triangle to understand it furthermore. So this is our triangle. Let's say this is A, B, and C, and this is angle Z. So let us solve it. So let's solve an example to clarify it. So let's say we need to, let's draw the question first. Let's say this is x, this is 8. Oh, damn, this technical problems again. Alright, never mind, just don't concentrate on that. So this is x and this is 10, and the angle we're gonna choose is 60. So how are we gonna find it? Now we are searching for x. Look, this is opposite, you see. So x square is equal to 10 square plus 8 square minus 2 times 10 times 8 times cos 60. I mean, yeah, cos 60. So x square is equal to 100 plus 64, 8 times 8, yeah, 64, minus 220 times 80, which is 160, plus times cos 60. What was cos 60 if we go further back? Yep, cos 60 is 1/2. So we write it here, cos 60 is 1/2. I mean, it could have been, the angle could have been 70, but when you type this, for example, when you type cos 70 in your calculator, I'm sure you will find the number. So cos 60 is just 1/2, because we know this because it's a common one. So let's continue. X squared is equal to 164 minus 160 times by 1/2, which will make it 80. So x squared is equal to 164 minus 80. X squared is equal to 84. So then we take it to the root. So we make it is equal to x. So this is the basic use of the cosine rule. Yeah, So now let's move on to the sine rule. Sine rule. What sine rule states is that a over sine A is equal to b over sine B and c over sine C. So what does that mean? Let's draw our triangle again and again and again. So let's say it's ABC triangle, so it is CB and A. This is the A angle, this is the B angle, and this is the C angle. As you can see, they're all opposite each other. Okay, so let's solve a question to clarify it a bit more. Let's go to a new one. Alright, let's technical problems. Okay, let's draw our triangle, and let's say this is 8, this is 10, and this is 20, and this angle is equal to, let's say 40, and this one is equal to, let's say this is 45, and this one is equal to x. So we have to find x. Let's use the rule, which is 20 over sine A, which is sine 45, is equal to, you remember here, is equal to B, so which is x, sine B under 10, so it is 10 over sine x. So it's 20 times sine x is equal to 10 times sine 45. Divide both sides with 10, 10, 10, 10, 10, so it's 2 sine x is equal to sine 45, and sine x is equal to sine 45 over 2. What was sine 45? Sine 45 was not this one, way back. Sine 45 was 1 over root 2. Sine 45 is 1 over root 2. Sine x is equal to 1 over root 2 over 2. Sine x is equal to 2 up, so it is 2 over root 2. So using a calculator you can find it. I don't have a calculator right now, but I'm sure you can do it. Alright, you want to solve another question with this one, and that will be the final question. Okay, let's go. Let's say, for example, let's draw our triangle again. Let's say this is the x now, so this, let's say this is 60 and this is 30, and this is 60, 30, this is a, and this is 2 root 3. Okay, so what was the thing? It was 2 root 3 over sine 60 is equal to x over sine 30. So we cross multiply first of all, so that would make it 2 root 3 times by sine 30 is equal to sine 60x times by x. Okay, let's look at what is sine 30. 2 root 3 times by sine 30. Sine 30 is 1 over 2, and sine 60 is root 3 over 2, 1 over 2, and root 3 over 2. Root 3 over 2. Sine 1 over 2, which is equal to sine root 3 over, what was it? Root 3 over 2. So root 3 over 2 times by x. From here we 2 root 3 over 2 is equal to root 3 over 2x, so that would be 4 root 3 is equal to 2 root 3x. We divide it now. It's 4 root 3 divided by 2 root 3. Cancel. That will make it 2 is equal to x, so x is equal to 2. So now we have came to the end of our session, end of our video. I would like to thank all of you for your patience, and this was video for teacher Mustafa, our math teacher. Well, I hope that I get 100, please.